how we can visualize these ethane molecule in different ways. Hello everyone, welcome back to Plutus STEM. So today we are going to discuss regarding conformational isomers. So as we are aware that we are already discussing all the isomers like configurational isomerism, constitutional isomerism. Over there we have already discussed all the subparts of constitutional such as chain isomers, positional isomer, ring chain isomer, functional group isomers, metamers, tautomerism. So all the isomers of constitutional, or you can say structural isomer, we have covered up. And regarding the stereoisomers also, we have covered up most of the part of that also, like configurational isomers. We have covered up geometrical isomers, optical isomers, also the enantiomers and diastereomers. So all the thing, if you need to watch around them, you can go, the link is being provided over here. You can go through the videos and watch them. So now we are going to discuss regarding the conformational isomers. So how these conformational isomers arises? So actually these are not truly the isomers, if I say, because these type of isomers, they arise due to a rotation around single bond. They arises due to the rotation of a carbon chain around a single bond. So when we are having a single bonded compound and we are seeing that some rotation is possible or not. So if I want to show you this compound over here, if you see, this is like we are having this type of this is like our carbon, this is our carbon and this carbon. So this is like fourth carbon are there. So if you tightly bound this so at this carbon you can rotate these all three bond like this. So if one carbon is being strongly hold down, so these three carbon can move like this. So this is the way how the rotation around a single bond is possible. But rotation around a double bond is not possible. The rotation around a double bond is restricted. We are aware that. So due to this possibility in the rotation, there arise some different structure, or you can say conformers or rotamers. They are being possible. So this is like, say, like I would like to show you, this is hydrogen, and this is hydrogen, and this is another carbon, fourth carbon. And if we rotate these bond, so what will happen? So this can rotate slightly. If one bond is rotating, so all the three will rotate like this, yes or no? So in this way, this is the actual position. Let's say this is the actual position where we were rotating this bond. So now the original position will be, after rotation, they will change their place. So enormous number of possibility of rotation is there, because this is a 360-degree angle is possible. So if we are rotating 1 degree angle each time, so 360 angle are possible. If we are taking a fraction of that angle also, so we can say infinite number of rotation are possible. Infinite number of rotation are possible around a single bond. So that's why we can say infinite number of conformers are possible. Infinite number of conformers are possible within a molecule. The molecule is rotating to get some stability. Everyone needs stability. So now we will see, is there some possibility arises over here that compound is having two different stabilized structure, or you can say conformers. Let's say if this is our compound CS3 and CS3, this is ethane. This is ethane compound. If we draw a sawhorse structure of this compound, it will be like this. This is carbon 1, this is carbon 2, one hydrogen, another hydrogen, and third hydrogen. One hydrogen, another hydrogen, and third hydrogen. This is carbon 1, this is carbon 2. Again you can say carbon 1 and carbon 2. This structure is Sawhorse structure, Sawhorse type of projection. So if we draw this structure into Newman, if we try to draw this structure in the Newman, so in the Newman what we do, we just see structure from here. If I am viewing structure from this side, so what I will view, let's say this is the circle, I will view these three hydrogen like this from upside, and this bond will be back side of this carbon, so they are back side like this. So these are on the back side. So this is carbon 1, that is upside, and carbon 2 is below the side, that is not visible to us. This is the Newman projection. How we can visualize these ethane molecule in different ways. Clear or not this thing? So this is the way. So if we rotate now, we try to rotate this molecule. So in this the rotation will be quite visible. So generally we see, study this conformational isomers in this projection only. So this is our ethane. Carbon 1, and below side is the carbon 2, and these are the hydrogen of carbon 2, and upper one are the hydrogen of carbon 1. So if we stuck these upper hydrogen like this only and try to rotate the below hydrogen by 60 degree, okay, so what type of projection we are going to get? Over here we will see this is a hydrogen, this is hydrogen, and this hydrogen, they are going to remain same, and now the rotation is at this angle, so it will come around over here or not, at this position after rotation, and this bond after rotation will come at this side 60 degree, and the third bond after rotation will come over here. So now if you compare both of these structure, if you compare both of these structure, so what you will visualize over here, if anyone asks you which one among these is more stable, so you can see this is hydrogen 1 and another hydrogen below the side like this. Some hindrance is there, but in the case the below hydrogen and above hydrogen are a bit far away from each other like this. So here some hindrance is there, and in this side no hindrance there. So this form is termed as staggered form. This form is termed as staggered form, and this form is termed as eclipse form. So if you see the stability, this is more stable and this one is less stable. This one is more stable and this one is going to be the less stable form. So this is for ethane molecule, and we can go through it some more molecule like propane. If we go for propane, CH3, CH2, CH3. So it will be like CH3, CH2, CH3, like this or not? Or can we make it further like this? this whole CH3 combinedly. Can we write it like this or not? So now if I try to write down like this in the Newman, hydrogen, 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 and over here hydrogen, hydrogen, and CH3. So this is a propane molecule. So if we want to compare over here now for propane molecule, so if we rotate this around 60-degree angle, CH3, HCH3 like this, H over here, H over here like this or not? Because these positions are fixed, we have just rotated these CH3 at this side, this H over here, and this CH3 at this side. Clear or not? And if we try to find out some more possibility over here, sorry. So if you see over here, this one and this one are quite same. Just the repulsion of CH3 and H over here also and here also. But at this side, the repulsion of CH3 and H. Clear or not? So there is some repulsion is there, quite possible, and this value is nearly 0.9, approximately equal to 0.9. This repulsion of CH3 and CH3H is so sorry, yeah, this one is 1, let's say. So it is like on the basis of this energy profile diagram, we draw it like this eclipse form, then like this. So this eclipse form, and this is like say is more stable staggered form. So staggered form is more stable, eclipse form is less stable. So they are interconvertible to each other. The same type of energy profile diagram can be made for this also, for ethane also. Let's say the upper one is staggered form, more less stable, and more. This is like more stable, which means the less energy. The staggered form and the eclipse form. Eclipse is less stable. So this type of conformational isomers can be drawn for various other hydrocarbons such as butane, pentane, hexane. We are going to discuss in the upcoming lecture regarding this butane. So over here we were just only having eclipse form and staggered form. In butane we will see regarding skew form or gauche form, fully eclipsed, fully staggered, anti-form. So many more things we are going to study in the upcoming lecture, in which we will discuss regarding the conformational isomers or conformation of this butane molecule and cyclohexane, chair form or boat form. This chair form and boat form, which one is stable, why this one is stable. So this all is going to be, we are going to discuss in the next lecture. That's all for today. Thank you.